Right, so I have shared my whiteboard. You would be able to see that in some time. Okay, so yesterday we were talking about angles, particularly angles in a circle. We discussed 6 properties, and now I'll talk about 3 more, and then we'll continue this discussion. Okay. So we are talking about the circle theorem. Right. So let's say we have a circle. This is the circle. And there's a point. Let's say this point, and we have 2 tangent lines. So this is the first tangent line, and then I'm going to make another one starting from the same point, this one, right? Okay. So this point is A, this point is B, and this point is T. This is the center of the circle, but I did not explain anything, so do not worry. Let me just make the drawing and then I'll talk about it, okay? All right. So yesterday we started this chapter where we started the discussion about angles in a circle. We have discussed the first 6 properties. Today I'll talk about 3 more, and then we'll talk about angles. And at the end, I'll do a past paper question just to see if we have understood this chapter or not. Okay, and then and tomorrow I'll talk about more past paper questions because this is one of the most important and difficult topics, right, in the O-levels math syllabus. Okay. These 2 maroon lines are tangents. I told you what exactly a tangent is. A tangent is any line that is touching the circle at one point only. For example, this is also a tangent line, right? This is also a tangent line. But for now, for this property, I am talking about the 2 maroon tangents because the property says that the length AT and the length BT, they are same, okay? And certainly since this line and this line, both of these, they are the radius of the circle. What is the radius? Any line that is starting from the center to any point of the circumference. It could be this as well, any line, right? So radius is same. So we know that the 2 radius would be same, AT and BT would be same. Another thing is that we discussed yesterday as well, the angle between the radius and the tangent is always 90 degrees, okay? Now these properties are very important and you should know them, right? Okay, this is the thing. And the other one is that if I make a line starting from here, okay, this is a line. Now I'll make this pink line again just so it is a proper kite. Yeah, so think about it as the kite property, right? And then you would be able to remember this. Okay, so this angle and this angle, they are exactly same because this angle is divided into 2 because of this yellow line. Okay, so I'll tell you all the parts of this property. This is one property, but we have multiple things in this. All right. The next thing is that this angle and this angle, they are also same. Right. That is it. So what do we know? The kite property says that the length of tangents starting from the same point, that is T in our case, is same. AT equals BT, okay? The second thing is that the angle, let's call it O, the angle ATO is equal to the angle BTO. Similarly, the angle AOT is equal to the angle BOT, right? Okay, and this thing that the angle between the radius and the tangent is 90, we discussed this yesterday. So we know that already, right? Okay, this is the idea about this. So anything that you did not understand? Yes, Saneem, Rania and Manur, is this clear?
Yes. Yes.
All right, okay. All right, so that is the seventh property. Let's talk about the next one. We'll finish all the properties and then we'll talk about the questions, because you know different properties are used in different parts of the question. So it's good that we talk about all of them and then we talk about the past paper questions. Okay. And in some books and in some, sites, you'll find 6 properties. Some would give you 9. That totally depends. It's good that you learn more properties just so things are easier for you. So property number 8 says that, let's say this is the circle and this is a chord of the circle. Let me just cut the extra bit. Okay. And this is the center of the circle. And this is a line, okay? This certainly, the black line, certainly it is not the radius because it is not touching the circumference. It's not touching the boundary of the circle. It's just stopping on the pink line. Now, the idea is this theorem has 2 parts, okay? You can use it either way. If this angle is 90, then it would mean that the black line has bisected the pink line. That means that the length of both these parts is same, okay? And let's say that you have been told that there's a black line and there's a pink chord, and this length and this length, they are same. So property number 8 says that the angle is going to be 90 degrees, right? So this is the idea. So I'll write it down. Perpendicular bisector. Okay, what is a perpendicular bisector? Perpendicular means 90 degrees angle bisector means it is dividing it into two parts. Okay, I'm just revising this for new students. We have already talked about perpendicular bisectors when we were talking about the equations of lines. Okay, so a perpendicular bisector of chord, that is the pink line. This is O, this is A, this is C, and this is D. Passes through the center. So OB is perpendicular to AC and AB is equal to BC, right? These are the two things which you need to understand. If OB is perpendicular to AC, AB would be equal to BC. And if AB is equal to BC, then OB would be perpendicular to AC, right? So you can think about them as a pair, right? So this is the eighth property or the second property for today. Any doubts about it? Anything that you did not understand? Okay. Please feel free to stop me if you are not able to understand anything. Okay. Right. And the last property for this is just like this one, the one which we have just discussed. So this time around, I am going to make two chords. One is here and the other one is here. Again, I am going to make the center of the circle, and there's a line that is perpendicular. Let me use a different color. So I have a black line that is perpendicular to the pink line. And then I have another line that is perpendicular to the other pink line, right? So the idea is, since they are perpendicular, the angle would be 90 degrees. Since the angle is 90 degrees, the length would be equal, right? So obviously the chord could be here as well. And the line could be this as well, right? This does not matter at all. So again, if this is a perpendicular line, then these two lengths are same. All right, so this was the ninth property. And yeah, that is the idea about circles, right? I'll do more. I do not want to use to explain all the properties on the same day. That is why I talked about 6 only yesterday. Then we did some past paper questions. Today again, I'll be using a similar pattern, right? Okay, so these were the 3 properties for circle theorems, but still in questions that are related to that topic, you need more information about angles. Okay, so we will talk about triangles now, and then I'll talk about the concept of two parallel lines that are being cut by a transversal in all those angles. Okay, and then I'll talk about a past paper question as well. Okay, I'll clear the screen and now I'll talk about triangles. So let's talk about triangles now. Let me make the 3 types of triangles we have. Okay, let me just connect these 2 sides. Okay, this is the first type. This is the second type. And this is the third type. Okay. This is the scalene triangle. This one is equilateral. And this one is isosceles. Okay, and I'll tell you what exactly do we know about this. Scalene triangle is that triangle whose every side is different, right? So all these sides are of different length. Okay, if I talk about equilateral, all the sides are of the same length. That is why it is called an equilateral triangle. And if I talk about isosceles triangle, so two sides are of the same length and the third side is of the different length, right? So that is the idea. Okay, so what do we know? We know that a scalene triangle has all different sides, equilateral has all sides equal, and isosceles has two equal sides. Now I'll talk about the angle side relationship. Okay, we are not talking about triangles, we are talking about angles. Okay, in an equilateral triangle, if any triangle has all sides equal, all the angles are going to be equal as well. And we know that sum of angles in a triangle is 180 degrees. So if all these angles are equal, this is x, this is x, this is also x. So what do we know? X degrees plus x degrees plus x degrees is 180 degrees. We need to find x. That's very easy. X plus x is 3x degrees equal 180. I can find x by dividing 3 on the other side. So x would be 60 degrees. This means that every equilateral triangle has equal angles and that angle is 60 degrees. Okay, so 60 degrees, 60 degrees and 60 degrees. All right, and in case of isosceles triangle, always remember that this angle and this angle, they are going to be equal, right? All right, so this is the idea. It would depend on this angle, so we cannot talk about these two angles right now, but yeah, this is the thing. So always remember, we need two triangles, equilateral and isosceles. In case of equilateral triangles, all the internal angles are 60 degrees. In case of isosceles triangles, since these two sides are equal, so according to the angle side relationship, you do not need to learn this term. Just remember that this angle would be equal to this angle. So if let's say this is x degrees, this would also be x degrees, right? Okay. These are the two important concepts about triangles, particularly about angles. And now we will talk about more angles. Okay, so any questions, Saneem? Did you understand this?
Yes, ma'am, it's clear.
Okay, Saneem, Manur, and Rania. Are you okay with this, all of you?
Yes.
Okay, that's good. Let's talk about another thing now. Again, we are talking about angles. Let's say we have two parallel lines. And how would you know if the two lines are parallel or not? You would not think, you cannot say that they look parallel. The examiner would give you such a symbol, right? If both of these lines have arrow on it, it means that they are parallel. Okay, so if you have two parallel lines that and they are being cut by a line, first concept is that this line, the yellow line, it is called the transversal. This angle and this angle, they are equal. So let's say if this is a degrees, this is also a degrees, and we call them alternate angles. Okay, so these are alternate angles. Okay, that is the first thing. If I talk about the same concept again I have two parallel lines and they are being cut by a transversal. First I'll make parallel and then I'll cut them by a transversal. So the idea is that this angle is equal to this angle. If this is B degrees, this is also B degrees. And we call them corresponding angles. Okay, so these are the two. Right, now I'll rub this and I'll talk about another property. That is, let's say this angle is G degrees, this angle is H degrees. They are co-interior angles. The idea is that H degree plus G degree gives you 180. Okay, so this is the third property. I'll write down the fourth one here. All right, so this angle is equal to this angle, and this angle is equal to this angle, and we call them vertically opposite angles. All right. So now I have a question for you guys. Let's see who's able to do it. I'll make the parallel line again. So this is the parallel line. Okay. So let's say I have this angle. It is X degrees. And I have this one that is 40 degrees. And I have this angle that is 140 degrees. My question is, what would be the value of X degrees? Can anyone tell me?
One 40.
Very, very good. Excellent. Well done. Okay. So I did not explain this, but we know that this is corresponding, right? If this is a line and this angle is being made between this line and the yellow line, same is the case over here. This is the red line and this is the yellow line. So the angle is going to be 140 degrees. Very good. Okay, that's good. Okay. So yeah, that was a simple question. I just wanted to make sure if you have understood this concept or not. Now I will talk about the last thing which we need to know. Some of angles in a polygon. What is a polygon? Polygon is any figure. It could be a triangle. It could be a quadrilateral. When we say quadrilateral, it could be any four-sided figure. It could be a rectangle. It could be a square. It could be any four-sided figure, right? So it could be a square. It could be a random four-sided figure. Okay. And then we have pentagons, hexagons, octagons, and stuff like that, right? The idea is sum of angles in a polygon. Now, a polygon could be a three-sided figure, a four-sided figure, a five-sided figure, a six-sided figure. We do not care about that. The formula is, it is 180 multiplied by n minus 2, and n is the number of sides that polygon has. For example, if I talk about a triangle, I have 1, 2, and 3 sides in a triangle. So sum of angles in a triangle would be 180 minus 3, oh sorry, not minus, 180 into n minus 2, that is 3 minus 2, and the answer is 180 degrees. That is why the sum of angles in a triangle is 180 degrees. What about a four-sided figure? Again, 180 into n minus 2, that would be 4 minus 2, because a rectangle has four sides. So 180 into 2 will give me 360 degrees, right? So now we know how to find the sum of angles in any three-sided, four-sided, five-sided figure. We only need to plug in the value of n. It could be 3, it could be 2, it could be 4. It cannot be 2. I'm sorry, it cannot be 2 because we do not have any two-sided figure that is closed, right? Okay, so that is the idea. Now I'll make the diagram quickly and we will talk about this past paper. So this is a circle. Then we have a point here. These are the two tangent lines. I'll drop the extra part. We do not need it. All right, the figure is not complete yet. Inside this, we have this is the center of the circle. This is A, B, C. This is T. This angle is 40 degrees. This angle is 5 degrees. And this angle is X degrees. Okay. That is pretty much it. Okay. I'll explain the figure first and then we'll see, okay? So we need to find okay. We need to find X and Y of this triangle. Okay. Now, if you think about it directly, you would not be able to do it. Okay. So you need to recall all the properties that we have discussed today and yesterday, just so you are able to relate to some theorems, and only then you would be able to do it, right? So what do we know? First thing is that this is the center and this is the circumference. That means that this is the radius. Similarly, O is the center and C is the circumference. This is also the radius. So this length and this length, they are same, okay? Right. Also, through the kite theorem, I told you that this length and this length, they are also same because AT and CT, they are the two tangent lines, right? Also, yesterday we talked about, and even today, that the angle between the radius and the tangent is 90 degrees. So this angle is 90 degrees. All right. What else do we know? Do we have information about anything else? Okay. That is pretty much it, right? So let's think about the solution for x degrees. Okay. For some time, just ignore the not this part. Okay, let me just rub this. Okay, and now think about it, right? So I'll just write it down once we have the value of x. Okay, so what do you think? This is a four-sided figure, and this four-sided figure has one angle at T that is 40 degrees, one angle at A that is 90 degrees, one angle at C that is 90 degrees, and the fourth angle at X. And we know that every four-sided figure has the sum of internal angles 360 degrees, right? So can we do this now? Yes, we can. I'll undo whatever I erased and now I'll talk about it. So we know that sum of
Can we add up this
Hmm,
all and
very good. Yes, and
minus it from 360?
very well done. Excellent, excellent. Yes, you are correct. Very good. Sum of angles in kite, square, rectangle, any four-sided figure, right? So it has a name. We call it oh, we have a message. Okay, very good. So Saneem got the answer right. Very good, very well done. Sum of angles in a quadrilateral is calculated this way. 180 into n minus 2, that would be 360 degrees. And we know that if it is 360 degrees, I'll write down all the angles that I have, 90 plus 90 plus x. I'll make x the subject and that is going to give me 140 degrees. Very well done. Excellent. So the answer is 140. Very good. So I'll write down the value of x and now we'll talk about y. So very good, both of you. And now I want you to think about y. Okay. I'll give you 2 minutes, think about it, and then I'll tell you. Okay. I want you to think about on your own as well, and then I'll tell you. Okay. Okay. So I got two answers. So one answer is that it would be 70 degrees, and the other answer is that it would be 180 because they are opposite angles.
No. I'm asking that
Hmm?
opposite angles is equal to 180 or it's wrong? Like if it
which
is
yeah,
equals to
yeah.
180,
Yeah, but
then we can
which
minus it from 180,
okay,
x and y.
X and Y. Yes, very good. That is correct in case of a cyclic quadrilateral, right? A cyclic quadrilateral is a four-sided figure whose all the endpoints or all the four corners are touching the circumference, right? So A, B, and C are touching the circumference, but O is not touching the circumference, right? So you cannot say that it would be 180 or not, right? Did you understand the idea that why it is not 180? The sum is not 180 because it is not a cyclic quadrilateral, right? The concept is correct. It
Yes.
would have been 180, but if it is a cyclic quadrilateral, this point is not over here. So that is what is not like that. Okay, very good
Yes.
attempts. Very good attempts, all of you. I'll tell you now. Saneem, you are very, very close to the answer. I'll tell you the thing. The thing is that yesterday we discussed a theorem that said angle at center of a circle is twice the angle at circumference, right? So if I talk about this arc that I'm shading, it is being made by the two lines OC and OA. Okay, so in short, it is being made by this angle, right? And the same arc is being made by the angle y degrees as well. So whatever the angle, the pink angle is, y would be half of that, right? Saneem, it won't be half of 140. It would be half of this pink angle, right? That is the only thing where you went wrong. So
Yes, I remember.
we need to find this angle. So sum of angles in a circle is 360. If it is 140, the remaining would be 360 minus 140, that is 220 degrees. If this is 220, y would be half of 220, right? So I'll write down the solution. Angle at the center of a circle is twice the angle at circumference. So if the central angle is 220 degrees, y is going to be half of that, and that is 110 degrees. So is this okay now, Manur, Rania, and Saneem?
Yes. Yes.
All right, okay, that is good. Okay. Now I'll write down the last question for today, and then that is it. Okay. Let's say this is the circle and this is a line, and then this is another line. This is a chord, and this is another chord. This angle is D. This angle is B. This angle is 83 degrees. This is C. And this one is 42. Okay, so you need to find A, B, C, D. Okay, I will not talk about the solution and I don't want you to tell me the solution. Take 2 minutes, think about it, and whatever angles you are able to find, just type them in the chat box. Okay, and then at exactly 6:50, I'll tell you the solution. So you have 2 minutes, think about it, and then do it. All right, so I have 4 messages. Okay, so for C, B, and okay. Very good, excellent. All of you, very good. And Manur, what about C and D? Rani and Saneem, very good and excellent, Manur. All your answers are correct. But yeah, okay, very good. Let me just do it as well quickly. So A is going to be 83 as well because they are vertically opposite, right? Okay, that is the idea about A. What about C? So if I talk about this arc is being made by the angle 42 degrees and the same arc is being made by C. So through a property that we discussed yesterday, we know that it is going to be 42 degrees as well. Now we have 42 and 83. I can find the angle D. Sum of angles in a triangle is 180. So 180 equals D plus 42 plus 83 is 180. So D would turn out to be 55 degrees. So it is 55 degrees. Okay, and what about B? B would be same as D because both these angles are making the same arc. 55 is making this arc and B is also making the same arc. So B would also be 55 degrees. Okay. And in exam, these all these angles would be for 1 mark. So the answer is just for the mark is just for the answer, right? So even if you forget the exact terms that how to explain this, that why it is that, it's completely fine. The examiner is going to mark you for the answer. Okay, And you will see that once we start doing the past papers, right? So that is it for today. We'll talk about more intensive examples from past paper questions. I just wanted to get smooth with this chapter. And tomorrow, inshallah, we'll talk about more past paper questions. Okay, so that is it for today. Anything that you did not understand, please feel free to ask me. Yes, Saneem, did you understand this? Okay. Manur and Rania, please tell me if you have any questions, anything that you would like to ask other than this.
No, ma'am.
Okay. All right. Then that is it, and I'll see you tomorrow, inshallah. Take care. Allah Hafiz.
Allah Hafiz.